Yes, so welcome once again to this class. And just a second, just wait a second. Okay, so I took the next page. Now we will learn about basic nuclear properties. We will start from the very basic, which is the basic nuclear properties. Okay, so put the heading basic nuclear properties. So what are the basic nuclear properties which we are going to learn? So we are going to learn about the nuclear size. Okay, nuclear size, which is also sometimes called as the radius of nucleus. Okay, nuclear size or radius of nucleus. What is the difference between nuclear size and radius of nucleus? That also I will tell you in the upcoming segment of this video. But right now, sometimes you right now assume that nuclear size and radius of nucleus are near about the same thing. Okay, depending on the shape we will say whether it is size or radius. If it is spherical, then we will say it, we will call it radius if it is a spherical nucleus. Otherwise we will call it nuclear size. Okay, but in general we use radius of nucleus. Okay, so radius of nucleus, then we have something called as binding energy, which we are going to learn in the upcoming classes. Okay, binding energy, then we have angular momentum. Okay, then we have parity, which we are going to learn. We are going to learn in this class. We are going to start with this. Okay, all these things will require further 15 to 20 classes. Okay, 15 to 20 classes will be required for this. Okay, then magnetic moment, we have something called as magnetic moment. Okay, magnetic moment. Then we have again semi empirical mass formula. Then mass parabolas. The last topic will be mass parabolas. Okay, so before moving on to the nuclear size, I would like to tell you something, that I am really sorry for one thing. Which thing? Sorry that I can't read the comments. Okay, I can't read all the comments. For this I am really very sorry. Okay, you should comment on the video. I am not saying that you should not comment on the video. When you comment on the video gets more views. Okay, the views of the videos increase. Okay, but the thing is, I can't read all the comments. Okay, you don't expect me to read all the comments. I can't read all the comments. Why? The reason is that I get about 25 to 30 comments I get each day. Okay, and when I was uploading the videos regularly, at that time I was getting 167, 168, so 172 comments like that. I was getting once upon a time, 4 months back, when I was uploading regularly. Then I was getting 167 comments, 172 comments, like that I was getting. Okay, so it is not possible to reply to all the comments. Okay, and not even I can't even read all the comments. So you keep on commenting, but if you have any doubt, in case you have any doubt, then you have my number. Okay, this is my WhatsApp number. This is my WhatsApp number on which you can contact me in case of any doubt or assistance. Okay, doubts or anything like that. Okay, doubts kind of thing. Okay, so this is the thing. Now nuclear size. What is nuclear size? Nuclear size. Majority of the nucleus are actually spherical in shape. Okay, what you learnt up to the 12th standard. Up to the 12th standard, you learnt that all the nuclei are, and let me tell you, nucleus is the singular form. Okay, nucleus is basically singular form, and nuclei is your plural form. Okay, so when to use this and when to use this, you should be clear about that. Okay, now what you learnt up to the 12th standard? What did you learn? Up to the 12th standard, you learned that nucleus is spherical in shape. Okay, up to the 12th you learned like this, that nuclei are spherical in shape, but that is a wrong concept. That is a wrong concept. You will come to know that some of the nuclei are prolate also and some are oblate also, like this. Okay, some nuclei are of this shape and some nuclei are of this shape also, and some nuclei are spherical also. So three type of nuclei are there: oblate, prolate and spherical. We are going to learn more about this in the upcoming classes, but for the time being, just accept this fact that whatever you learnt up to the 12th standard, that the nuclei are spherical in shape, that is a wrong concept. Nuclei may be oblate, prolate or spherical. Okay, so three shapes of the nuclei are possible, that is oblate, prolate and spherical. Out of those, spherical shape is the most common shape of the nuclei. Other two shapes are also there, but they are not very common. Okay, other two shapes, that is the oblate shape and the prolate shape, are not very common shape of the nuclei, but majority of the nuclei are spherical in shape. Okay, so this is not circular. Okay, whenever I draw like this, whenever I draw like this, it is not a circular. You should imagine in 3D. You should imagine it like a ball. Okay, you should imagine it like a ball. Okay, so nuclear size, in the nuclear size heading, put the heading nuclear size and write over there. What should you write? Majority of nuclei are spherical. Write over here. Majority of nuclei majority of nuclei are spherical. Very few show deviation from spherical symmetry. Okay, very few show deviation from spherical symmetry. Okay, so majority of nuclei are spherical and very few show deviation from spherical symmetry. So those that show deviation from spherical symmetry are either oblate or prolate. That also you know. Okay. Now there are many type of moment. One of those is, there is monopole moment, dipole moment, and quadruple moment. Okay. So monopole moment, dipole moment, all those things are already you have learnt in the lower classes. Okay. Now I want to tell you one specific thing, which is the quadruple moment of the nucleus. Okay. Those who have learnt electrostatics of paper 1, Those of you who must have learnt about electrostatics of paper 1 of physics optional, those people might be knowing what is a quadruple moment. Okay, there it is taught, but over here also, in this particular series also, what is quadruple moment, it will be taught to you. Okay, so but in the upcoming classes, not in this class, but for the right being, for the time being, just consider it like this, just accept the facts as it is. Okay, so quadruple q is equal to quadruple moment of a nucleus. Okay, so how is it represented? It is represented like this. Okay, 1 upon e, sorry, 1 upon e will come over here. Okay, so 1 upon e integration rho 3z square minus r square d tau. Okay, so this is the quadruple moment of the nucleus. This is the formula. Where do you learn this? You learn this in the paper 1 of electrostatics, and in this chapter also you will learn about more about it in the upcoming classes. Okay, so don't worry that you don't know the meaning of this. So quadruple moment is given like this actually. I am just writing this formula so that those who have already learned will be able to imagine properly. Okay, but if you haven't learned this concept yet, then there is no need to be worried about it. Okay, so q is equal to 0 for spherical nuclei. Okay, so q is equal to 0 for spherical nuclei. And this is the thing which you have to remember, bear in mind. Okay, bear this thing in mind, that for q is equal to 0 for spherical nuclei. Those nuclei which will be spherical in shape, for those q value, that is the quadruple moment, will be 0. Suppose if quadruple moment is greater than 0, or suppose if quadruple moment is less than 0, then what will happen? Those nuclei are not non-spherical. Okay, so instead of writing like this, you can also write it like this: q not equal to 0 for non-spherical nuclei. Okay, so for a nuclear to be spherical, its quadruple moment should be equal to 0. Okay, now we will learn about spherically symmetric nuclei. We will learn about a 12th class concept now. So what you have learned in the 12th class, we will learn now for spherically symmetric nuclei. For spherically symmetric nuclei, V is directly proportional to A. Okay. Now what is the V? V is actually volume of the nucleus. Okay. For spherically symmetric nuclei, you have to remember this thing, that V represents the volume. Okay. Volume of nucleus, and your what is A? A is the atomic mass number. Okay. Now volume of the nucleus is very clear to you. Okay, volume means the space which it occupies. Okay, volume just implies that how much space it will take. Okay, how much space it will occupy. That is the volume of the nucleus. That how much space it will occupy. Okay, it is related to space occupancy. Okay, for example, eraser your eraser, suppose if you have an apsara non dust eraser, suppose it is a apsara eraser, so it is occupying some space, so it has volume. Okay, so like that nucleus will also have some volume, although comparing nucleus with this eraser is not a good comparison, because your eraser is a macro object and your nucleus will be a micro object. So on the nucleus you will apply actually quantum mechanics, not Newtonian mechanics. On your nucleus you will apply quantum mechanics, not Newtonian. But on the eraser you will apply Newtonian, not quantum. Okay, so that is the difference. But for the time being we are thinking classically. For the time being we are thinking classically that if there is a nucleus then it will occupy some space. Okay, so it will have some volume, and that volume of the nucleus for a spherically symmetric nuclei I am saying, you must remember this thing. This thing is valid only for spherically symmetric nuclei. Okay, so up to the 12th standard whenever you learnt about nucleus you only considered that nucleus are spherical. You used to learn in the 12th standard that nucleus is spherical in shape. But that is a wrong concept. I already told you that oblate and prolate are also the two types of shapes which a nucleus may have. Okay. So volume of nucleus is directly proportional to atomic mass number. You have to remember this thing. Now what is this atomic mass number? What is this atomic mass number? There the students are very much confused. I have seen the students getting confused between atomic mass number. Students get a lot of confusion over here. Okay, so let us think classically right now. Okay, so if this is the atom, suppose, okay, if this is the whole thing is atom and that dotted thing in the center, this dotted thing is suppose the nucleus. Okay, so what will be the atomic number? So this nucleus, when I will break it into parts, its constituents. So you must have learnt in the lower classes that it comprises of protons and neutrons. In the nucleus what are there? Protons are there and neutrons are there. Okay, in the nucleus only these two things are there. Okay, nothing else is there, only protons and neutrons are there in the nucleus. Okay, no meson is there, no positron is there. Okay, those things are not there inside the nucleus. Electron is always outside the nucleus, in the shells. Okay, electron will be in the shells outside the nucleus. Okay, it is wrong to say that electron is revolving. I had already told you in the quantum mechanics class that electron exists in the form of electronic cloud. Okay, it does not exist in the form of a revolving planet. Okay, that is a totally wrong concept, because planet is a macro object and electron is a micro object. I had already told you. Okay, so we cannot consider, we can only say that electron cloud is there around the nucleus. Okay, but when I talk about the nucleus, I will I will not talk about electron or any other particle. When I talk about nucleus, I am restricted with protons and neutrons. Okay, so nucleus, uh, a normal nucleus, I will say rather, a normal nucleus, a nucleus which is found in nature. Okay, in nature whatever nucleus you find. Okay, for example, if you take the electric switch of your house. Okay, suppose, or if you take the pen which you have in your hand. Okay, if you take the pen and if you take out the individual atoms out of your pen. Okay, if you suppose break the pen so mercilessly that individual atoms are coming out of it. Okay, this is also a hypothetical example. Individual atom cannot be isolated. Okay, individual atom is very difficult to be isolated. uh, Scientists have been able to isolate 100 atom group. Okay, scientists have been able to isolate a group of 100 atoms, 1000 atoms, like that. Those come in the nanoparticle range. Okay, those are called as nanoparticles. But an individual atom, is was it possible for the scientists to isolate an individual atom? क्या एक एटम को आइसोलेट कर पाए हैं साइंटिस्ट? एक एटम कि भाई ये एक अकेला एटम मैंने निकाल लिया, एक एलिमेंट का एक एटम को मैंने सेपरेट आइसोलेट कर दिया, ऐसा क्या साइंटिस्ट कर पाए हैं क्या? तो नहीं कर पाए अभी तक, ठीक है। जो कर पाए हैं वो सिर्फ 100 एटम के लिए कर पाए हैं, ठीक है ना। 100 एटम का ग्रुप या 1000 एटम का ग्रुप, ऐसा छोटा सा नैनो क्लस्टर का ग्रुप, वो साइंटिस्ट लोगों ने आइसोलेट कर लिए हैं सक्सेसफुली, लेकिन एटम को नहीं कर पाए, ठीक है ना। तो अगर ऐसी सिचुएशन बनती है, सपोज इफ देयर इज अ कंडीशन, ओके, सपोज अ सिचुएशन अराइजेस where you are able to isolate a single atom, okay. So if you look at the nucleus of that single atom which you have isolated from the pen, from your ballpoint pen, you have isolated a single atom, and if you look at that atom and study its nucleus, okay, this is the atom and you will study its nucleus, okay. So if you try to study its nucleus, then in the nature whatever nuclei you will get, those will contain only protons and neutrons, okay. Those will contain only protons and neutrons, nothing else. No electron will be there in the nucleus, okay. Nucleus will always comprise of only two things, protons and neutrons, okay. So the atomic number that is represented by Z, what is it? It is the number of protons in the nucleus. And what is atomic mass number? Atomic mass number means A, okay. A is the atomic mass number, which is equal to the number of protons plus number of neutrons, okay. What is atomic number? It is Z. Now chemist, the chemistry people, and I am also teacher of chemistry also. Along with this, I also teach chemistry also. So their atomic number is a very important concept, because the position of atom in the periodic table, position of an atom in the periodic table will be determined with the help of atomic number, right? So that you even if you have left chemistry after 12th standard, okay, you don't have to worry that you don't understand the atomic number, because atomic number has almost no use over here. Almost it will be useful, but not much, not very much useful for physics people. For physics people, atomic mass number is very useful, okay. So total number of nucleons is equal to your total number of protons plus total number of neutrons, okay. So atomic mass number, what is atomic mass number? It is equal to total number of nucleons. Atomic mass number is equal to total number of nucleons, and which is equal to number of protons plus number of neutrons, and these are present inside the nucleus of the atom. This is the nucleus, so protons and neutrons will be there inside this nucleus. So why are they being called as nucleons? Nucleons because they are present inside the nucleus, okay. Resident of nucleus, that means nucleons. Resident of nucleus means nucleons. So proton has +1 charge, okay, neutron has 0 charge, okay. So all these things you have already learnt in the lower classes, okay. The number of protons is the atomic number, and number of neutrons plus number of protons is the atomic mass number, okay. You have learnt this. Then one more concept is there, which I was telling you already over here. So volume of nucleus and atomic mass number, you have learned this. So for spherically symmetric nucleus, volume of nucleus is directly proportional to atomic mass number, and this is given even in HC Verma. Okay, so we are starting from HC Verma and going to the advanced level. So this is given in the HC Verma also, that volume of nucleus is directly proportional to atomic mass number. So now you have learnt in lower classes. What did you learn in the lower class? In the lower classes you must have learnt one thing, that volume of a sphere. What is volume of a sphere? Let me write over here, okay. Now this is a spherical volume, okay. So if a sphere is there, okay, if there is a sphere, suppose, Suppose there is a sphere, and suppose this sphere has a radius. Okay, it has a radius. Then what did you learn in the lower classes? In the lower classes you have learned that volume of a sphere. What is volume of a sphere? It is equal to 4 by 3 pi r cube. Didn't you learn this? Yes, you have learned this. That radius of a sphere, if it is capital R, then volume of the sphere will be 4 by 3 pi r cube. Just put this value, as our nucleus is also spherical. Okay, as the nucleus is also spherical, we are thinking classically. Right now. Okay, so consider the nucleus to be a small sphere. Okay, very small sphere. Okay, very small sphere. So that small sphere is also going to have some radius. So let us assume that radius to be capital R. Okay, so volume of nucleus will be 4 by 3 pi r cube. This is directly proportional to A. Now you know this, that the proportionality sign. Okay, this proportionality sign, whatever you have over here, this proportionality sign can be written without the help of constants also. So the constants can be removed from here. 4 by 3 is a constant and pi is a constant, so those things can go away from here. So r cube is directly proportional to A, you will get. Okay, that is the cube of, what does this mean? What does this mean? R cube is directly proportional to A. Okay, that simply means that cube of radius of the nucleus is directly proportional to its atomic mass number. Okay, so cube of radius of nucleus is directly proportional to its atomic mass number. So this is given in the HC Verma also. This is a class 12th concept. Now I will take cube roots on both sides. So taking cube roots on both the sides. Now when I took the cube roots on both the sides, you know this very well, that cube root is equal to, okay, cube root of A is equal to A to the power 1 upon 3. You have learned this in the lower classes, right? Cube root of A is equal to what? A to the power 1 by 3. Okay, and similarly square root of A is equal to what? A to the power 1 by 2. Okay, similarly fourth root of A, what is it equal to? A to the power 1 by 4. And nth root of A, what is it equal to? It is equal to A to the power 1 by n. Okay, you have learned this, so you will simply take 1 by 3 power. Okay, A to the power 1 by 3. So these 3 and these 3 will cut out. Okay, and after those 3 are cut out, what you are left with? You are left with r is directly proportional to A to the power 1 by 3. Okay, so r is equal to r naught A to the power 1 by 3. This is the constant of proportionality. Whenever directly proportional sign is removed, whenever the directly proportional sign is removed, what do you get? Proportionality constant. And that proportionality constant over here is r naught. Okay, so right over here that this R naught, it is like this. Where is this proportionality constant between atomic mass number and radius of the nucleus? Okay, what is this atomic mass number of the nucleus? Atomic mass number of the nucleus, and what is this radius of the nucleus? Okay, okay, so this R naught is basically your proportionality constant. Okay, so this R naught varies slightly, from one nucleus to another, but is roughly constant for atomic mass number greater than 20. Okay, so this R naught value varies slightly from one nucleus to another. Okay, now this proportionality constant is not constant for every nucleus. Okay, it is not constant for every nucleus, although the value will be almost a constant type will be there, but not exact constant. Okay, so it varies slightly from one nucleus to another, but it is roughly constant for a greater than 0. For atomic mass number a greater than 0, not greater than 0, sorry, greater than 20, for atomic mass number greater than 20, this R naught value is roughly a constant. Okay, but below 20 values, okay, it varies. Below 20 it varies, but after 20 mass number it will have roughly a constant value. And after 20 value, what is it? R naught. Okay, for a greater than 20, for a greater than 20 nuclei, for a greater than 20 nuclei, what is the value of R naught? Okay, below that it varies a lot, but after 20 atomic mass 20, it will be almost a constant. So it is something like this. The R naught value is something like this: 1.2 plus minus 0.1 into 10 to the power minus 15. Okay, so it can also be called as Fermi, or it can also be called as Fermi or femtometer. Both are same. Okay, what is FM? It is femtometer. Okay, femtometer. So this is the value of R naught. Now what does this mean, that plus minus mean? What is the meaning of this plus minus? Plus minus means you must have learnt in your lower classes, right, about the error in measurement. It is not a measurement error here. Here it is not on account of your uh, error of measuring something. Okay, it is not like that. Over here this error is coming because you are changing the nucleus. Okay, for a greater than 20, suppose for 8 is equal to 21. Okay, suppose for a is equal to 21, the value is 1.3 Fermi. Okay, and suppose for a is equal to 25, it is suppose 1.1 Fermi. Okay, these are not value, I am saying. Then for a is equal to something else, it will be, so it will keep on varying between 1.1 Fermi to 1.3 Fermi. Okay, that means Write over here, value of R naught varies between 1.1 Fermi to 1.3 Fermi. R naught value varies between 1.1 Fermi to 1.3 Fermi for atomic mass numbers greater than 20, that is A greater than 20. Okay, so you can write like this, or if you want to write, you can write it like this also. Okay, okay, but this is not your representation. Okay, but this, like this maths people represent it like this. Okay, so if you remember a little bit of maths, so you will be able to a little bit understand it in a better way. Okay, so just forget this is just for fun. Okay, so value of R naught is between this and this formula is given in the HC Verma book. Okay, this is your HC Verma formula. Okay, this formula is from HC Verma. So now we will keep the class this much only, this class. Okay, then density of nuclear matter I am going to discuss in the next class. Okay, so thank you very much. If you haven't subscribed to our channel, then please do subscribe to the channel. Okay, and if you want to give any donation, means if you want to donate something, then you can donate on the Paytm number 724918. That number, WhatsApp number, is the Paytm number. So if you want to give any donation to me, donation means uh, voluntary donations. Okay, for voluntary donations, voluntary donations. So this is my Paytm number for voluntary donations. Okay, or if you want to give some voluntary donation, then you can contact me on this WhatsApp number. Okay, so thank you very much. Jai Hind, Jai Bharat.